Hello, now we're going to talk about test first and incomplete specification. I'm putting these two subjects together because there are some controversy about it. So there is no silver bullet in software. So it's everything is a trade-off. Everything depends on. So it's knowledge is discussing these trade-offs. And so the first thing that you need to know about test first, and probably you have to start exercising it. Maybe it looks awkward to you. Is the advantage of it, and it looks like an overhead. But I don't think that it's necessarily an overhead because actually it's just a way of thinking before doing. Okay, and I know that I'm claiming a lot of times that say we think by doing, but of course we need to think always a little bit before we start, and then we learn by doing, and we rethink. So this is a iterative process. But the question is, before I implement a method, I need to think a little bit about it so that I don't get surprised at the middle of the implementation, so that something changes. And a way to think is actually thinking about which cases, which are the common cases that you want to address, which are the corner cases that needs a special treatment. And so if you do this thinking by writing test cases, it helps you to that afterwards, as when we implement the code, you can test the code, okay? And that's one big advantage. What may be strange afterwards is that if you do this, you will realize that most of the times when you implement your method, it has no bugs. And you may ask, well, that was really easy. Why should I add I just lost time. I lost my time writing the tests. But actually, it's the opposite. You just implement it correctly because you wrote the tests. You thought about it. Of course, there's always this question whether, well, maybe I'm just writing it for the tests I wrote. But then the answer is, well, it happens like this. It's just maybe you could not think about all the cases. But at least you know that for what you have thought about, the code is working. And the test will be there forever. Okay? And besides being there forever, another advantage of doing this is you can do debugging. When you do debugging, you can debug your code in the context of a test. Okay, and there's an article that that you can read. I'm pointing to it in the documentation, where we refer the difference between debugging and testing. And one way to look at it is that when you debug, you set up a lot of context to check things, and at the end of the debug, you just fix the bug and you lose all this work. If you write a test and then you debug in the context of the test, you don't lose the context anymore. You just start executing the test, and the debugger starts in the particular context you want to debug. Okay, so there are nice symbiotic relations between these things. But of course, there is a problem, and some people argue that maybe tests is not the right way to go. Why? Because tests are an incomplete specification. As I told you, what happens is that, yes, I'm writing the tests, but at the end, my code works for the set of cases that I defined. And why is this an incomplete specification? People that argues about this is people that tries to describe your code in a much more precise way so that you define all the cases. How can this be done? Well, this was done a long time ago, first by Tony Orr, that defines preconditions and postconditions, and which define the precise behavior of an entity. So a precondition defines in which states should be the program before these entity is invoked, and the postcondition describes what should be the state after the invocation. Okay, and although this was a theoretical work, it was applied in programming languages like Eiffel. So I'm going to show you what happened in Eiffel, which is a very old language, not I think that not used anymore, but that included very nice ideas. Okay, so it is called design by contract. Okay, and the idea of design by contract is this idea of preconditions and postconditions. The best way, just I'd show you an example. Okay. Suppose that you have this traditional put an element. Okay. So what are you going to do? First, you're going to define, so it only contains the specification. You only define in which case this can be invoked. So in which case you ensure that the behavior is going to be correct. So if this put method is not invoked in these conditions, basically forget. Who's going to implement it do not guarantee that it behaves correctly. So if the count is less than the capacity, and if the key is not empty, well, this is the code, and it ensures that there's an element. Okay, so the element that you insert exists, that given the key, you get the element, and the number increments. So they use these old to means that the old value. So the old value of count before the invocation. And so if you think about this, you think, well, this is completely described. I'm not just described for one or two values. I'm describing it for, I have a complete description. Now, how do I guarantee the correctness of this? And what happens, and that is the difficult part, you need to use logic and you need to use tools to guarantee this. What has been changing is that something that was quite computational demanding in the past, so it was not practical, now tools are becoming more powerful. So maybe now we do a lot of we are really concerned about the correctness of our programs using tests, and maybe with new tools, more powerful, we'll move to things like this where you define the specifications. And we'll find languages which today, not Eiffel, that pick these ideas and are becoming closer, not yet, but closer to be used in an industrial context. So software engineering is like this. You need to know different concepts and be prepared for the evolution of the technology that sometimes pick old ideas, and due to advances of hardware or algorithms, you just can start and applying in the industry things that were not possible before. So that you realize the difference between a complete specification and an incomplete specification. The incomplete specification provided by the tests. Look, in this case, in the test for the put, we just define, for instance, x equal to 5, dictionary count equal to 10, and then key equal to 1. And then you verify this. So it's incomplete because we are just doing it for these values. While if you have a complete specification like in Eiffel, and if you have the computational ability to prove the correctness given the specification, then things will be much better, okay? But of course, I think that it's not yet the time, okay? So test case is an incomplete specification, and the point is, can I take advantage of test cases or of complete specifications? Actually, if you look at this complete specification, so you can decide, okay, I'm going to use testing because the practical way I want to run thousands of tests or even hundreds of tests in my system, okay? For instance, in nightly builds. But I would like to be more rigorous when I think about. So this test first, you can specify first using try to write a complete specification. And then if you look at this complete specification, Actually, you can use, for instance, equivalence partitioning and boundary value analysis, and then identify some test cases. But actually, is it what you do? You have a specification in your mind, but of course, you can also try to write it in some type of language. So to finish, and please read all the documentation, because then we'll see that besides pre and post conditions, we have invariants as well. But to finish, what I would like to tell you is that, or at least repeat, there are always these trade-offs, okay? And you need to prepare for things that are going, may change, may not change, okay? It was, when I started learning programming, I learned in terms of pre and post conditions. After a while, people just say, forget, this is not going to work, never. Now it looks like this is returning. So as an engineer, you need to acquire the tools and the concepts so that you be prepared, because things change, and which make it quite interesting. So these understand what is the deep meaning of this test first, the idea of incomplete specification, and the idea of being able to have a complete specification. Okay, so good insights.